Ever wondered how data is stored and manipulated in programming? That's where the concepts of variables and data types come into play. They are the building blocks of any programming language, and understanding them is key to mastering programming itself. Imagine a variable as a box. It's a storage location in your program that holds a value. You can name this box and refer to it later to retrieve or alter the contents inside. Before you can use a variable, it needs to be declared. That's like saying, hey, I've got a box here and it's going to hold this type of stuff. For instance, you might declare an integer variable named age, but a box isn't much good until it has something in it. That's why we have initialization, which is just a fancy word for putting a value into your variable. So you might initialize your age variable with the value 25. Now, there are some rules to naming these boxes or variables. They must start with a letter, an underscore, or a dollar sign. You can use digits, underscores, or dollar signs for the rest of the name, but steer clear of reserved keywords. Also, each variable has a scope, which tells you where in the program it can be accessed. Some variables are local celebrities, known only in a specific part of the program, while others have a global reputation and can be accessed anywhere in the code. But what about the stuff inside the box? That's where data types come in. A data type is like a label on the box that tells you what kind of value the variable can hold. There are primitive data types like integers, doubles, characters, and booleans, and then there are reference types like objects, arrays, and user-defined types. Some languages even allow type inference, where the compiler plays detective and deduces the type of the variable for you. And there's more. There's the intrigue of dynamic versus static typing, where variables either get to change their type during the program or are stuck with their initial type. In short, variables and data types are the dynamic duo of programming. They help us store, retrieve, and manipulate data in our code. Stay with us as we delve deeper into the fascinating world of variables and data types. First off, what exactly is a variable in programming? Let's dive right in. A variable is akin to a storage box, a name location in a program that holds a value. It's like a label attached to a piece of data, allowing you to reference and manipulate that data throughout your code. So how do we use these handy storage boxes? Well, before you can use a variable, you have to declare it. Declaration is like saying, hey, I have a box and I'm going to call it age, and it's going to hold an integer. In Java, this would look like int age, an integer variable named age. But a storage box isn't much use if it's empty, right? This is where initialization comes in. Initialization is the process of putting something into the box, assigning a value to the variable. We can do this at the time of declaration or later in the program. For example, in age equals sign 25, we've just put the value 25 into the age box. Naming our variables is important, but there are some rules to remember. Variable names must start with a letter, an underscore, or a dollar sign. Following characters can be letters, digits, underscores, or dollar signs. But avoid using reserved keywords. They're like VIP parking spaces in the programming world, off limits for variable names. Now let's talk about scope. No, not the mouthwash. The scope of a variable refers to where in the program it can be accessed. It's like having a storage box in your house that only you can access. That's a local variable. But a box in a public library? That's a global variable, accessible from anywhere in the program. Now that we've got a handle on variables, let's move on to data types. So, stay tuned, because things are about to get even more interesting as we delve into the world of data types and how they interact with our newly understood variables. So, what do programmers mean when they talk about data types? Imagine data types as different containers that can hold various kinds of information. Each container has its own rules about what it can store and how it can be used. In programming, a data type is a classification of data that tells us what type of value a variable can hold and what operations can be performed on it. Let's delve into the most common data types in Java, one of the most popular programming languages. First, we have the primitive data types. These are the most basic data types, and they include int for integer values, double for double precision floating point numbers, char for single characters, and boolean for true or false values. There are also other numeric data types like byte, short, long, and float. On the other hand, we have reference data types. These include objects, arrays, and user-defined types. Think of them as containers that can hold complex data structures or even other containers. Now let's take a look at a concept called type inference. This is a feature in some programming languages, including Java 10 and onwards, that allows the compiler to infer the data type of a variable from its value. For instance, if you write var name = John, the compiler understands that name is a string, even though you didn't explicitly state it. But wait, there's more to learn about data types. Let's discuss dynamic typing versus static typing. Have you heard about dynamic typing and static typing? Let's demystify these terms. First, let's tackle dynamic typing. In a dynamically typed language, the type of a variable is checked during runtime. This means that the same variable can hold values of different types throughout the course of the program. A simple example is Python. In Python, you can assign an integer to a variable, then later assign a string to the same variable without any error. This gives programmers a lot of flexibility, but it can also lead to unexpected bugs if you're not careful. On the other hand, we have static typing. If you're using a statically typed language, the type of a variable is checked during compile time, not runtime. This means once you've set a variable to be of a certain type, you can't change it later in the program. Java and C++ are examples of statically typed languages. Here, if you try to assign a string to an integer variable, you'll get a compile time error. This can make your code safer and more predictable since you know exactly what type each variable is, but it can also feel more rigid and less flexible. Now you might be wondering which one is better? Well, it really depends on what you're trying to achieve. Dynamic typing can be great for quick prototyping and small projects where you need flexibility and speed. Static typing, however, can be beneficial for larger, more complex systems where you want to ensure type safety and predictability. It's also worth noting that some languages offer a middle ground. For example, in recent versions of Java, you can use the var keyword to let the compiler infer the type of a variable based on the initial value. This gives some of the flexibility of dynamic typing while still maintaining static type checking. Remember, whether you choose to use dynamic typing, static typing, or something in between, the key is to understand the implications of your choice and use it to your advantage. Now that we've got a clear understanding of dynamic and static typing, let's see these concepts in action. Time to see these concepts at work in a real-world example. Let's dive into a simple Java program. Here we declare and initialize 4 variables: age, height, gender, and isStudent. Each variable has a different data type: int, double, char, and boolean, respectively. The variable age is an integer that stores the value 25. Height is a double precision floating point number that holds the value 5.9. Gender is a character type variable that stores the letter M, and isStudent is a Boolean variable that holds the value true. These different data types allow us to store and manipulate different kinds of information. For instance, the integer data type lets us perform mathematical operations such as addition or subtraction on the age variable. Similarly, the Boolean data type allows us to use the isStudent variable in conditional statements. But what happens when we try to perform an operation that isn't compatible with a variable's data type? Well, the Java compiler throws an error. For instance, if we try to add 2 to the gender variable, the compiler will reject our code because addition is not a valid operation for character data. Next, we print the values of our variables to the console. This is done using the system.out.println function, which prints the specified message followed by a new line to the console. The ++ in the print statement is used to concatenate or join the text message with the variable's value. So when we run this program, it prints out age 25, height 5.9. Gender M is student, true. This simple example demonstrates how variables of different data types can be declared, initialized, and used in a Java program. It also shows how the data types of variables determine what operations can be performed on them. Remember, understanding variables and data types is key to writing clear and efficient code. It's like knowing your ingredients before you start cooking. You need to know what each one does and how they interact with each other to create a delicious meal. And there you have it. That's how variables and data types work in programming. We've covered a lot of ground today, haven't we? We delved into the world of variables from their declaration to initialization. We explored various data types, both primitive and reference. We compared dynamic and static typing, and even saw these concepts in action through a practical example. Remember, understanding variables and data types is a fundamental step in your programming journey. Keep practicing and you'll master these concepts in no time.